any value that's calculated with data from an entire population is a population parameter, and any value that's calculated with data from a sample is a sample statistic. At this point, you might be wondering why they don't just call them sample statistics and population statistics. Why do they have to use the word parameter? Well, it's really just statistical jargon. In statistics, they decided that they wanted to have one word for a value calculated from a sample and another word for a value calculated with data from an entire population. So don't worry about why this one is called a statistic and why this one is called a parameter, because they are pretty much just sample statistics and population statistics. So let's look at some examples. Let's start by looking at some examples of population parameters. The mean of a population is a population parameter, so the mean age of all college students in the US would be a population parameter. The median of a population is also a population parameter, so if you found the median age of all college students in the US, that number would be a population parameter. The standard deviation of a population would also be a population parameter. So if you were somehow able to calculate the standard deviation of the ages of all people in the US, that number that you calculated would be a population parameter. I said that any value calculated with data from a sample is a sample statistic. So let's look at some examples of sample statistics. The mean of a sample would be a sample statistic. So if I randomly selected 250 college students who live in the US and calculated the mean age of those 250 people, the value that I calculated would be a sample statistic. The median of a sample is also a sample statistic. So if I selected 250 college students who live in the US, recorded their ages, and I found the median of those 250 people, that median would be a sample statistic. A standard deviation that's calculated with data from a sample is a sample statistic. If I selected 250 college students who live in the US, recorded their ages, and then I calculated the standard deviation of those 250 ages, the value that I've calculated would be a sample statistic, because it was calculated with data from a sample. So I said that any value calculated with data from an entire population is a population parameter, and any value calculated with data from a sample is a sample statistic. Usually, population parameters can't be calculated because a population parameter can only be calculated after data has been recorded from all members of the population. And we know that it's usually not possible or practical to collect data from all members of a population. So, since researchers usually can't calculate population parameters, what they do is they collect data from samples, preferably random samples, and then they calculate sample statistics to estimate the population parameters that they're interested in. And we said that the process of calculating a sample statistic to estimate a population parameter is called statistical inference. So using a sample mean to estimate a population mean is statistical inference. Using a sample standard deviation to estimate a population standard deviation would also be statistical inference. Now let's end the video by looking at some of the symbols that are used for common population parameters and for some common sample statistics. The symbol for population mean is the Greek letter mu, which looks like the letter U. The symbol for a population variance is the Greek letter sigma, which looks like an O, with this exponent at the end, and it's called sigma squared. And the population standard deviation symbol is just sigma. The reason why the population variance is sigma squared and the population standard deviation is sigma is because the standard deviation is just the square root of the variance. The symbol for a sample mean is x bar. It's called x bar, but it's just an x with a bar above it. The symbol for a sample variance is s squared, and the symbol for a sample standard deviation is just the letter s. So all of the symbols for population parameters are actually Greek letters, and all of the symbols for sample statistics are just regular letters, just common letters. So if you're reading an article and someone is reporting a sample mean, a person might just say x bar equals this number. Instead of saying the sample mean is this number, they might just say x bar equals this number. Or if they're reporting a sample standard deviation, the article might just say s equals this number. So this is the last point that I wanted to make in this video. So thank you for watching.